today we're just going to be continuing our core series, which is super important. You guys know that the core series is like the foundation for everyone's math. So it's super important that you guys are taking big old notes for all of these. So make sure you get your notebook, pen, pencil, Notability, whatever you use to take notes, because we're about to deep dive in some of the math stuff. While we're going through it, please feel free to unmute, ask questions. Feel free to throw it in the chat box like, oh, this doesn't make sense or whatever. That's completely cool. We can take as much time as we need because we're a little bit ahead of schedule so far. You guys have been doing a really great job, but it's definitely okay to slow down with anything. If you have any questions or need something re-explained, we're here for that. Absolutely. So that's pretty much it for today. Oh, since I got the cut, people just say what's up, like pretty much. I went to a gathering this weekend, and that was a good time because everyone was like, "Yo, what's up?" It's like they didn't recognize me at first, which was pretty good. I liked that one. That was pretty cool. But yeah, for the most part, it's been cool. It's been good. So without further ado, if everyone has their notebook and paper and all that good stuff out, we're going to get going through core 4. We're going to finish up. So I think the last thing that we worked on was compound inequalities and all that good stuff. Oh wait, no, we didn't. I put a new note on this page for something else. So we definitely didn't do compound inequalities. Before that, though, we were talking about inequalities. Yeah, that's it. So let me get like a thumbs up or a 1 in the chat if the last thing in your notes is inequalities. And then Kelvin, if you could throw the blank doc in the chat again, that'd be awesome.
Yeah, you got it.
Okay, so the last thing that you remember was remainders. Awesome. So that's remainder theorem. That means we're ready to go with inequalities. Awesome. Perfect, perfect, perfect. All right, so we're going to wait to throw the PDF in the chat for a little bit. If you guys have any questions about anything in the notes, just review your notes for a little bit while this is going on. Let me know if there was anything specifically that you're like, dang, I need to go over that again, so that we can talk about it. Make sure all of you guys are feeling good about everything.
And just like Asher said, right, make sure you have your notebook, pencil, calculator, and make sure y'all are checking the recaps, right? They have all the annotated copies for all these core documents, right? And make sure to go back and review the concepts that you struggle with, because again, we're going through this material pretty quickly, right? And in order to ensure that it's sticking, right, you want to make sure you're reviewing and practicing, right? Through Sarah, practice tests, doing practice questions. Just give me an R in the chat. You've been making sure to review the annotated copies. Awesome. Okay. So it's the same PDF that we were working on last week. Here it is in the chat, core 4, student copy. Make sure you pull it up.
Yeah, so for you Notability users and all that stuff, you should probably work on the same document if that's what you're doing or you tried to do that for. But it's also cool to check out the blank document to just follow along.
Yeah, and if you have the blank document in front of you, like in your notebook, just keep it organized, right? Just on the top, right, core 4 continued, and then title it like, remainder theorem, inequalities, and then take notes on the main things, and then come back and fill it in right after class.
Sarah, have you checked out that new Homer merch at all? What do you think about that stuff? Or did you not see like the magazine and all that stuff? Okay, so Frank Ocean came out with like a new luxury fashion line, and it's just like a bunch of like pendants and like rings and stuff. In the catalog,
I saw the Instagram post and everything, but I haven't like checked out the merch or anything. My friend's gonna get it. My friend wanted to buy some. I was like,
dude, it's like $4,000 for a pendant and stuff. Like, it's crazy high.
Yeah, you have to have money to buy that stuff. So,
dude, it's crazy. But some of the stuff looks cool. Like, it's like, oh, that's a cool direction. That's dope. And like, at least we get cool like magazines that he worked
Yeah,
on.
I thought like when I saw the post and I saw like his story for a second, I thought it was like an album. I was just like, so excited. I was like, wait.
Yo, me too. I was like, yo, Homer's coming out. I don't need to worry about all those other albums that are supposed to drop but aren't dropping.
Yeah.
Sick. Dope, dope, dope. Excellent. So continuing with inequalities, I think you guys pretty much got this, so we're going to fly through part of it. So inequalities, if it's facing towards something, that's the bigger thing, right? So in this case, x is more than, x is less than. And then here, when we have the line under, that's or equal to. So that just means like it includes that value. So x can be greater than or equal to 5 means that 5 is an acceptable value, but then everything above 5 also is acceptable. So that comes up a good bit. And we also need to make sure that we understand how to graph those. Get rid of this note down here. Boom. So whenever we're solving an inequality, we solve it like an equation, just like a y equals type deal. You move it the same way. You do everything the same way. The only thing that's different is the fact that you have to flip the inequality when you're multiplying or dividing by a negative number. So just remember that. That's probably the biggest note about inequalities, you guys. Flip it when multiplying or dividing. I could never remember when to flip it. I was like, oh, there's a negative number in here. I need to flip it. That's not the case. It's just when you're dividing or multiplying. So over here, Daniel, why don't you help us out? What is this going to become once we solve 5x is less than or equal to 20? Yeah, you.
4.
What about 4?
Wait, am I the right Daniel?
You can be the right Daniel.
Okay. X would equal 4.
Not quite, because we have this less than or equal to, right? So how do we write that? X is
less than or equal to 4.
Beautiful. Exactly. That's what I'm talking about. Perfect, perfect, perfect. So that's great. And then Daniel Cuesta, why don't you help me with this one? Is it Cuesta or Cuesta?
No, you surprised me. That's right. The first one was right.
Nice.
All right, so we're dividing by -5. So it is going to be -4, but then you're going to flip the sign.
Perfect. So what's that become?
That becomes x is greater than or equal to -4.
Excellent. Really good stuff. Nice. So we flip that one. Perfect. Here's some more notes about imaginary numbers that we were talking about earlier. We're going to take those away because it's compound inequality time, right? So we deal with functions the same exact way whenever they're compounded like this. All you need to do, there's two ways to tackle this. You can either do everything at once to both sides, or you can split them up. So the way that I generally do it, I'll call it way number 1. You can make it like a -11 is less than or equal to 2x plus 5. And then under that, or like next to it, you could say 2x plus 5 is less than 7, and then solve these independently. Or 2, you can solve them at the same time. So your first operation would be to subtract 5 on both sides. So you'd have -16 is less than or equal to 2x, which is less than, and then remember you're subtracting that over there, so that's 2. And then we divide by 2 on both sides, so -8 is less than or equal to x, which is less than or is less than 1, like this. But I usually prefer it this way. I feel like it's neater. It's easier to keep track of. In this case, you're still going to get that x is greater than or equal to -8. And in this case, you're still going to get the fact that x is less than 1 over here. So this still works, but you can do it the other way as well. And then here's just another example problem with that. Okay, sweet. So over here, we have graphing inequalities. It's the same thing. This is just y is greater than, y is less than, or we have like under versus no underbar. So if we have an underbar, that means solid line. If we have no underbar, that just means dot or dashed line. And if it's greater than, it means shade above. If it's less than, that means shade below. It's really just like that. Don't worry about left and right, just worry about up and down when you're dealing with these. So let's check out this question below. Graph y is greater than 2x minus 1. Logan, how you doing today, man?
Doing good. A little bit
Excellent.
tired, but I'm doing good.
Excellent. Good to hear. I feel that way too, bro. It's like 5, but I don't know why it feels like 9 or something like that. But with this here, like, how would you tackle a question like this, Logan?
I would first move the 1 over, so it would be y plus 1 is greater than 2x.
I think that's a really great idea when we're trying to solve for x. But in this case, when we're graphing, we kind of want to treat it like y equals 2x minus 1 at first, because that's what our line is going to look like. Does that make sense?
Yeah,
So where would your first point be, for instance?
it would be at -1. It would be 0, -1.
Perfect. What would your next point be?
And then it'll be give me a second. It'll be at 1, 1.
Perfect. Really good. So there we kind of got the basis for our line, right? And before we draw our line, we need to decide, is it going to be a solid or dashed line?
And it is going to be dashed because it's not equal to.
Perfect. Exactly. Killing it, dude. So it's going to look like something like this. We got our nice little dashed line. And now what's our last step?
It is to shade above.
Nice. Perfect. And that's exactly correct. We just shade above right here, and that's your answer. That's it. So really great stuff, Logan. Just everyone remember, whenever we're graphing an inequality, treat it just like a linear equation at first, and then do the linear inequality stuff. So like make sure you keep in mind if it's dashed or solid, and then shade above or below afterwards. So over here we have the same type of question. In which of the following does the shaded region represent the solution in the xy plane to the system of inequalities above? So the trick to these questions is to get them both in slope-intercept form. So this one's good. We like this, but we don't like this. So we're going to rearrange this, right? So to rearrange, we're just going to take 2x to the other side. 3y is less than or equal to -2x plus 6. Then we divide by 3. So y is less than or equal to -2/3 x plus 2, like this. Now that they're both in standard form, I want you all to private message me with your answer, A, B, C, or D, using the different properties of linear equations that we were talking about before.
So when you're graphing this, it might be easier, right? To just draw your own graph, right? So everyone make sure you try to do that, right? And remember how the shading works, right? So if it's greater than your shading above, you're going to be shading above the positive line and below the negative line, right? And the solution is where the shadings intersect.
Exactly. So just keep in mind, you guys, the lines are written all the same every time. So they're not testing, can you draw the lines out? It's pretty much like, okay, what are our inequality rules? So the minute that you know that this is negative and this is positive, you don't need to worry about like checking where the lines are. You just need to worry about, okay, where should I shade at this point? Because you know that definitely this has to be equation 2 and this has to be equation 1. So we'll call this 1, we'll call this 2. You definitely know that just based off of how they're written, positive versus negative. And then from there, you shade in. So what are we thinking? Okay, I got a couple answers. At this point, I want you to just throw the answer that you think at this point. If you're stuck between 2 or you're stuck between anything, just drop the answer that you're most inclined to do. And awesome, really good stuff, you guys. So perfect. We got a lot of correct answers, but let's go through this just in case. So the first thing that we know, let's just draw our own little graph down here at the bottom. So we have our own little coordinate. We know we have a negative line and a positive line like this. And we know that the positive line is above. So over here, we know we're shading above. We'll do this with circles. So all the solutions to the positive line are circles, and then all of the solutions to the negative line, we see that it's below here, right? So since it's less than, it's below, then you just draw like a different shape. So we have asterisks or X's, I guess. And then you just want to pick the location where you have circles and X's. So that's going to be over here. And just like you guys said, that's going to be answer choice B based off of this. Any questions on this problem over here?
I'm a little confused.
Okay.
My brain's hurting right now. How do you know where like the greater sign and you were saying greater and less than for the shades, but I don't understand that. That kind of like confused me.
Yeah.
I'm a little
Yeah.
lost.
So over here, can you agree with me that this represents the positive line? Do you know where I'm getting that from?
No.
So we're saying that this is the positive line because whenever we're dealing with inequalities, you want to kind of treat them like y equals x plus 2 first. And then treat this one like we rearranged it and got y is less than or equal to negative 2/3 x plus 2. So you can treat that kind of like y equals negative 2/3 x plus 2. Does that make sense, kind of?
Yeah, that makes sense.
So
Okay,
you want to
what-
think y equals mx plus b, right? So essentially, just as Asher said, you want to first ask yourself, what is the slope, right? So for the first equation, what's the slope, Gabriel?
For the first equation, it's y equals x plus 2.
So what would the slope be?
1.
1, right? So that's positive, right? Positive 1. So we know the positive line is going to be the one that's going up from left to right, right? And then the negative line is one that's going down from left to right. And then you want to think of shadings with, you see how it says y is less than or equal to, or y is greater than or equal to, right? So if you ever see y is greater than, or y is greater than or equal to, however the line looks, try to put it flat, and you're going to shade basically above that line, right? So above the positive line, right, is essentially the left side of the line. Do you see that?
Yeah, all I was trying to figure out was why you were shading it above or below. The greater than or equal to thing wasn't clicking for me. Thank you.
Okay, yeah. So whenever you see greater than, that means above. And then whenever you see less than, that just means shade below. Does that make sense? So
Yeah.
this will clue you into where to shade. And the bar underneath the or equal sign determines whether it's a solid line or a dashed line. So if it had been y is greater than x plus 2, your line would look like this instead. Does that make sense?
Yeah.
Okay, excellent, perfect.
And then real quick, Gabriel, if it's y is greater than, look at that line that Asher just drew. Are you going to shade, like, technically, you're not supposed to think like this, but the left side, 1 or 2?
1.
1, right? Because above the line just means think up or down, okay?
Perfect, really good stuff. So I think you got this, right, Gabriel? You feeling good?
Yeah.
Excellent, perfect. All
I
right,
have another question actually.
yeah, go for it.
You said that when we divide, like you did for the second equation,
Mhm.
we should flip the sign. So why is that not the case here?
That's a great question. So over here, the next step to this question is 3y is less than or equal to negative 2x plus 6. Do you agree?
I mean, yeah.
Yeah, when we're just solving for y equals mx plus b form. Now, what do we have to do to get y
So
by
real quick, Catherine, right? To get to that step, right? From the original equation, right? We subtracted 2x on both sides, right?
hmm
When you add or subtract, nothing happens to the sign, right? And then what's the next step, Catherine?
To divide it by 3.
Divide by a positive 3, right? So the only time the sign flips is if you multiply or divide by a negative number, okay?
Okay.
So addition, subtraction, or dividing by positive numbers does not flip the sign.
Thank you.
Yeah, really great question. So just like Kelvin said, if you add or subtract negative numbers, you don't need to worry about it. It's only when you're dividing or multiplying, and we divided by a positive 3. So any other questions before we continue? Got some good stuff. Okay. So over here we have absolute value. I love this page. This is one of my favorite things to teach is absolute value. Over here, usually the way that we think about absolute value is that it just means all positive, right? So if anything's in here, it gives us all positive values. So regardless of what's in here, it's going to spit out a positive. So -4 is just going to be 4 or whatever. So whatever negatives you have in there, it's going to end up being positive, right? And that's pretty much it. If you have something like absolute value of x minus 4, this expression just doesn't change. It just depends on what you plug in for x. So over here, if you have -2 is x, then you'd have -2 minus 4, absolute value of -6, which just gives you 6. So don't ever just change the inside here because there's a negative in there. Don't worry about that. You don't change the inside expressions until you're actually plugging something in there, right? And we'll talk about how to solve these in a second. It also stands for, this is the cool part. I'll show you guys why in a second with a really dope drawing. It's going to blow all of your minds, hopefully, because it blew my mind. And like, that's why I love teaching this. So D is the distance. And that's it. You just remember D is distance. A is any coordinate. So distance from A is how you could rationalize that. So let's say, instead of this, let's say I ask you to find numbers that are 3 away from -2. All right, so in this example, let me see, I'm gonna put Sarah on the hot seat. How are we gonna construct this equation? What is our distance in this question?
Your distance is 3, and then your A is -2.
Yeah, exactly. Perfect. So what's that going to look like when we plug that all in?
So it'd be 3 equals the absolute value of x plus 2, since you're doing, yeah.
Perfect. Really good. That's excellent. Absolutely. And here, this is a really good segue into actually how to solve an absolute value equation. Oh man, don't do that. Don't do that. I can't. I hate it when Notability does that because now it's gone forever. But just remember, it's 3 away from -2 was the template. Now, once we get this equation here, to solve an absolute value, all you do is make 2 different equations. One where it's just like the equation without the absolute value sign. So 3 equals x plus 2 would be your first equation. And your second one, all you do is make the constant negative, or you make the other side negative. So -3 equals x plus 2. It actually doesn't matter which side you make negative. You can make it 3 equals -x minus 2 if you want to. But for the sake of simplicity, that's why we're making it just -3. So we do it like this. And then afterwards, we just solve for x. So x equals 1 over here, x equals -5 over here. And now this is the cool part. We have a number line. We know the number we're talking about is -2, right? That's the one we want to figure out. We got our 2 solutions are 1 and -5. So if I have a solution of 1, that has to be 3 away from -2. Pretty big brain, right? But now -5 to -2, dude, that's also 3. So graphically, you can understand why this equation makes sense or why this format makes sense. We have a distance of 3, and -2 is like our anchor point, like the point that with respect to our distance, right? And that's why we get our 2 solutions like this. So in other words, if you ever see a question like this, you can think of, okay, what's 2 values that are 3 away from -2? And then think, okay, I can either add to -2 or I can subtract from -2. And that might speed up the process if you can think like that.
And another way you can also look at it, right? So zoom into that equation, right? So whatever's in the absolute value when it has to be 3, right? When you take the absolute value of it, right? So you could think of, well, we know the absolute value of 3 is 3, and then drop it in the chat. The absolute value of what other number is also 3. So which is why, right? X plus 2, right? Can either be 3 or -3, because when you take the absolute value of either of those numbers, you're going to get 3, right?
Perfect. Yeah, absolutely. Really good stuff. And yeah, that's pretty much it for here. This is pretty much my example that I just did, but just on a different page. So over here, this is, okay, before you guys see this real quickly, the reason why we teach you stuff like this is so that you can get through questions way faster. You can get through them way more efficiently instead of having to solve everything out. So with that in mind, I want you guys to try and solve 28 without having to do any math. Just look at this, read it, think, oh, what did I just learn? And then private message me at A, B, C, or D. If you have a question or you don't really understand how to do without math, feel free to just drop a question mark.
And this is kind of testing on whether you took your note on the equation, right? Well, you have the PDF, so look back at that equation, okay? Distance equals absolute value of x minus any number a, right? And then private message me when you get your answer.
I got a bunch of answers already, Kelvin. Do you want to just take this question
No,
away?
that's good.
Okay.
Sure, yeah. So it says 2 different points on a number line are both 3 units from the point with coordinate -4. So 3 units from just means, guys, what's the distance going to be in the chat? Drop it in the chat. 3 units from, which means you're going 3 away from a certain number, right? So we know the distance. So we know this equation is going to be equal, like 3 equals or equal to 3, right? And we're going away from which number? A is basically -4, right? So remember, it's x minus a, which means it would have to be x minus -4, right? Which would be the distance of 3 is equal to the absolute value of x plus 4. Great job, right? And let's say like, oh man, like I forgot the equation on the test, right? All you got to do is draw a quick number line, right? We're going through, just like Asher drew, right? We're going 3 away from -4, so we put -4 in the middle, right? And then we're going to think, okay, 3 away to the right would be -1, so adding 3, right? 3 away to the left, -3 would be -7. And then those are the solutions, right? -7, -1, and then we can just plug in and see which one works in the answers, right? And that works too. But just like Asher said, memorizing how like absolute value functions work will make this a lot faster.
And the alternative to doing it conceptually, like we talked about it there, would it be to try out every answer choice. Now, that's not the best way to do it. It's going to take a long time. But let's just have a quick review. How do we solve these? Does anyone want to volunteer to solve this for me? X plus the absolute value of x plus 4 equals 3. Any takers?
Sure.
Nice. Give it a go.
So you split it into x plus 4 is equal to -3 and x plus 4 is equal to 3. And
Perfect.
Then you subtract 4 and you get x equals -7. And subtract 4 again and you'd get x equal to -1.
Nice. Really good. Perfect. And then we know that those are both 3 away from -4. So that's excellent. Really good stuff. All right, perfect. And number 8, this is another conceptual one. Feel free to just drop this one into the chat whenever you get this. Remember, what's the biggest rule about absolute values we know? Apply that to this question, and that's pretty much it.
And it's also converting like words into equations, right? So set it up and then think logically.
Okay, cool. So I got 5 responses. If you're still thinking about something, just drop it now so we can talk about it. And if you got a question mark, just throw any answer down. Because remember, we don't leave any questions blank on the SAT. So always put down an answer, even if you don't know. Okay, really good. Awesome. So let's talk about this real quickly. So we're asking for what value of n minus the absolute value of n minus 1 plus 1 equal to 0. So all that means is n minus 1 plus 1 equals 0. And now we're trying to solve for n. So our first step, move the -1 over. We have the absolute value of n minus n minus 1 equals -1. So at this point, Logan, why don't you tell me what's wrong here?
Well, no matter what value you would put in for n, it would automatically come out as positive due to the absolute value.
Exactly, perfect. So there's literally no way that we could get -1 here because absolute values always spit out a positive. Now let's think about something else here. So D is the correct answer, but I want to hear your guys' thoughts on something like this. Let's say we have something like n plus 600, whatever, I'm just coming up with numbers, plus minus 700 equals -500, something like this. Is this allowed? Can I do this? So put a Y in the chat for yes, this is allowed, or in, you're not going to get any solutions, dude. No solutions for this one. What are we thinking? Woo! Whoa, you guys are killing it. Yeah, absolutely. I was expecting to get some of you guys, but no, you said no. So yeah, you can add the -700 to the other side, get n plus 600 equals 200. And since this is a positive value, this is definitely an eligible equation. We can definitely do this. So really good stuff, you guys. Next, we have fractions. Okay, if you have like an immense hatred for fractions, let me get an H in the chat real quickly. I want to see my fellow compatriots.
And the good thing about that is the SAT hates fractions too, right? So if you can get rid of fractions, that's like your first goal, right? So that's like one thing the SAT agrees with you guys on, all right? So keep that in mind.
Nice. I'm so happy. I have so many fellow fraction supporters / haters. So here's how this works. I was always freaked out by fractions too. I hated them myself because I didn't know what to do. But now we have a really cool guide and it's all in one place. So you don't need to worry about going from like 6th to 7th grade and then being like, oh crap, we didn't go over everything at the same time. So we got all of this at once. Whenever we're adding or subtracting, the key is a common denominator. So in order to add or subtract, you need a common denominator. So in order to get a common denominator, let's think about a couple things that we need to do. We don't want to change the value of any of our fractions, right? We want the addition to stay the same to get the same value. So in order to do so, let's take a look at this. So we got 5/6 plus 2/3. What's our common denominator going to be, you guys? Or the least common denominator? What are you guys thinking? Killing it, absolutely. So in order to get that least common denominator, what do we have to multiply 2/3 by?
And be more exact about what we're multiplying by, because 2 is 2 over 1, right? So what are we actually multiplying by?
So think about that, y'all. If we just go around multiplying stuff by 2, that's going to change the value, right? So if I ask you, okay, what's 5 plus 10? And then you're like, oh, I want to rewrite this in a different way. I'm going to make it 5 plus 20. I'm going to get a different answer, right? So if I just multiply it by 2, that's the same thing as going from like 15 to 25. It changes the value of the addition, right? You don't want to do that. So just like you guys are putting in the chat, instead of multiplying by 2, we want to multiply by 2 over 2. And why is that? Does anyone want to clue me in here? Why are we multiplying by 2 over 2 instead of 2? Nice. Brianna got it in the chat. Absolutely. So it's because we're multiplying it by 1. 2 over 2 is the same thing as 1. So it makes sure that our fractions are equivalent still. So 2/3, as you guys could probably agree, is the same thing as 4/6, like this. You can simplify it either way. You know that they're equivalent. And that's why we're multiplying by 2 over 2, because they're going to be equal fractions, right? Now over here, we can do that addition. So we got 5/6 plus 4/6. That gives us 9/6. And this isn't on this page, but let's try and simplify this real quickly. What is this going to go down to, you guys? Feel free to always unmute if you want to, but you can always just drop it in the chat as well. Yeah, perfect. So 3/2. The way that we simplify fractions, you just pick a factor that's in both of these and then factor it out of both of them, and that's okay. So you got 3/2, just like you guys put. Over here,
We just add to that. So in this case, right, we only had to multiply one fraction, right, by 2/2, right? But let's say you're looking at more complex fractions and you need a common denominator, right? So if you could zoom in, just write 1/a plus 1/b. Sorry, a and b. 1/a plus 1/b. Cool. So anytime you want to get a common denominator and it's not that simple, all you got to do is multiply one side by the opposite denominator over itself, right? So you would just multiply 1/a by b/b, right? And then you multiply plus, right, 1/b by a/a. Yeah. And that's going to work for like getting a common denominator for any fractions.
Perfect. Yeah, absolutely. So make sure you're taking notes on this. It comes up on the SAT a good bit. Fractions are a necessity in math, unfortunately. So it's good that you guys get a solid foundation on this. Next, we have subtracting. It's actually the same exact thing as adding, so you guys don't need to worry about this. Anyone want to just walk me through this real quickly? For subtracting.
The first thing you want to do is get a common denominator. So you would times the 3/4 by 2/2.
Nice. Absolutely. So that's the tricky part right there, Logan. Killed it. And then 7/8 minus 6/8 gives us what?
Gives us 1/8.
Perfect. Really good. And then always remember, whenever we're adding, it's always just across the numerator. Subtracting just across the numerator again. Killed it, dude. Absolutely perfect. Now, when we're multiplying, this is fun. I love multiplying fractions because it's not bad. All you do is multiply across, multiply across. So multiply across with the numerator, multiply across with the denominator. We got 5 times 3 gives us 15. 7 times 2 gives us 14. And that's it. Now, whenever we're dividing, this is a little bit trickier. I never understood keep, change, flip because I'm like, what are we keeping? What are we changing? What are we flipping? Right? Instead, I think, okay, here's the first one. I'm gonna keep that. Oh wait, I'm gonna accidentally say keep, change, flip while I'm teaching this. My bad. So we're gonna keep this 5/7 here. We're gonna change the operation from division to multiplication, and you're just gonna flip this one over here. And by flip, we mean the reciprocal. And guys, remember, the reciprocal is just flipping the denominator and numerator. It has nothing to do with making it negative. That's only for perpendicular lines. So that's a common misconception. We've addressed that a couple times now, but just keep in mind, reciprocal is just when you flip. Perpendicular is when you flip and then make it negative. So that's different. That's the negative reciprocal, right? So over here, just flip this and we get 3/2. So we get 15/14 once again.
And just to rewrite that example, right? Typically on the text, you'll see something like 5/7 and with another fraction like over, right? What is that? 2/3, right?
It is not letting me zoom in today, dude. I'm sorry. So you got 5/7 over 2/3.
So that's probably how it'll show up on the test, right? So remember, keep, change, flip, like keep the first, change the sign, flip the second, or keep the top. Division means, right, change division multiplication, and then flip the bottom. So keep the top, change the sign, flip the bottom.
And then it's our best friend multiplication again. We love multiplication. It's easy. Just go across and that's it. And then the last thing that we have is cross multiplying. Whenever you set one fraction equal to another fraction, ooh, this is fun. That just means you're going to cross multiply. So what does it mean to cross multiply? You multiply across. So that's fun. It's easy to remember just by the name of the operation. So cross multiply, multiply across. So in this instance, when we multiply across, we get 4 times x. So that gives us 4x equals, when we multiply across this time, gives us 35. So x equals 35/4 when we solve that out. And that's all you need to do. Whenever you see a fraction equaling to a fraction, and one of them just so happens to have a variable, it's easy pickings. It's just a cross multiply question.
Also, real quick, another important point. So real quick, just write like x over 5 equals 5 over 10. No, 10 over 5.
Over 5 equals.
No, not 10 over 5. Let's do 20 over 5.
You got it. 20 over 5.
And actually change the 5 to 3 because that's too obvious. All right.
You got it.
There you go. Okay. So guys, yes or no? Can we simplify 20 and 5 to 4 and 1? Yes or no in the chat? Can we simplify 20 or 25 to 4 and 1?
Got some no's in the chats. Got some yeses in the chat. Okay, nice. We got some debate.
Okay. Versus, right, x over 5 times 20 over 3. Let's say you had that, right?
Yeah, this is one of the biggest rug pulls in math history.
So it's a huge misconception, right? So remember, guys, when you have something like two fractions equal to each other, you cannot simplify across, okay? So you can't cross out 20 and make that like divide both by 5, right? Make it, what's that? 4 and 1, right? So you can't cross simplify it when you have two fractions equal, okay? But when you're multiplying, you can simplify across or up and down, right? So we can actually cross this out and make that 4 and 1, right? Give me a 1 in the chat if that makes sense, right? You can't cross simplify when you have two equations equal, but you can simplify when you're multiplying. Yeah.
Perfect. Another thing over here, let's assume that this was like 10. We are allowed to simplify horizontally over here whenever you're cross multiplying. So if that makes your life really easy, then do that. You can simplify this way. So you can turn this 1 into 2. But just remember the different rules for each one. If you cross multiply and you simplify across, that's going to change one side of the equal sign. It's going to imbalance it, which would be rather unfortunate. All right.
Yeah, and in that example with the fractions equal, right? If you get the denominators the same number, the numerators have to be equal the same value as well, right? So if it was like x over 5 equals 20 over 10, but you multiply that left side by 2 over 2, right? Which would be 2x over 10 equals 20 over 10, and then 2x would have to equal 20, right?
Yeah, absolutely. And then, do we have any questions about fractions before we move on? We're not really going to talk about them in depth again for a little bit. So what are you guys thinking? Good? Okay, cool. Next, we got dimensional analysis. That's just a fancy way of saying unit conversion. So here's how I like to do this. First thing you want to identify is what do we want? We want inches. What do we have? We got feet. Let's think about this. What I want is inches. So I got inches over here. And then feet over here. So I got 15.5 of them. I don't want feet, right? I want inches. So now over here, this is where you multiply by your conversion. So remember, step 1, put the unit you want over here, put the unit you have over here, and figure out, okay, how can I cancel this, right? So if I want to cancel feet, is feet going to go in the numerator or denominator, you guys? So put N for num, D for denominator. What are we thinking? Oh, you guys are killing it. Perfect. Yeah, excellent. So if we want to cancel out feet, we're going to put in the bottom. And let's say there's 1 foot. There's 12 inches in every 1 foot. So you do it like this, multiply them. So now we got 15.5 times 12 gives us 15.5 times 12 inches. Nice. And then, yeah, here's just the equation to go with this, the question for this. You know, I'll leave this example up here, give you guys a couple seconds to work it out, and then drop it in the chat whenever you guys are feeling good.
And this is a question you could technically do in your head, but practice dimensional analysis, okay? You always start with given, and then you convert 1 unit at a time. And we're doing number 6, which is Daniel, the question right here. How many 1 milligram doses are there in 2 decagrams?
So it looks like all the answers I've gotten so far on the money. Yeah, perfect. Nice. Okay, at this point, just drop the answer that you're thinking in the chat, and then we'll talk about it if need be. But I think we're chilling. Like we're chilling with D. Okay, cool. Yeah, everyone got D. Really good stuff, you guys. Perfect. Now up we have proportions and percents. Okay, proportions are going to be super important for one of my favorite topics in all of math. It's going to be some like circle business that we're going to be doing a little bit later, but it's really fun. I love those proportions over there. But for the most part, part over whole, fraction is over of. We don't really need to worry about all this. Percent means out of 100. So always remember that percent is x over 100. So the same thing over here, 35% is the same thing as 35 over 100. Super important that you guys know that because we go over that a lot. Pretty much it. Percent change. You guys actually need this one. This comes up on a lot of practice exams. These are probably the curveball questions that are stumping students, even though they look easy. So just remember, percent change is new minus old over old, or like what I like to say is new like a cow, but with an N instead of an M. So like N minus O over O. And then you guys know what new and old are. You just plug those in, right? So percent increase. So percent change is this. And then let's talk about percent increase. So percent increase, same thing as before, is 1 plus percent. Percent decrease is 1 minus percent. This is a quick check-in there.
And guys, it's so important that when you deal with percents, don't like neglect this topic, right? You always start with 1 and you're adding or subtracting from 1. And that's the decimal you're going to use in the equation, okay? So let's just go ahead and like just a quick example. Let's say you go from like 70 sales, right? 70 sales this week to 120 sales next week, right? And you want to figure out the percent increase, right? So new minus old, what's it going to be? Is it going to be 70 minus 120 or 120 minus 70 in the chat?
Yo, how are you getting A, B's, C's, and D's for this question? Like, we didn't put A, B's, and C's for those questions, you guys. Like, what? You guys are crazy. Okay, good. Perfect.
There we go, right? So new minus old will be 120 minus 70 over what in the chat? Over 70, okay? And Ash, if you want to include absolute value, are you going to take the absolute value of that, whatever you get, and they're going to multiply by 100, right, to convert it to a percent, right?
Yeah, so you can include the absolute values. I always leave them out because if it's negative, you know it has to be decrease. If it's positive, you know it has to be a positive percent change. So you can do that. Percent change is like a positive type deal because the change, regardless of if it's negative or positive, is a value. But like it's just nice to know which way you're going. So yeah, do make sure when they ask you for the percent change, you take the absolute value of it, but it'll tell you if it's increasing or decreasing once you take the absolute values brackets on it. So 50 over 70, perfect. Multiply that by 100, and then that's your percent change.
But be careful, right? So just include that absolute value times 100 because that number you're going to get is a decimal, right? So it's important to understand that that's not the percent. It's going to be, you got to whatever you get. For example, this one you get 7.71, right? So that would be a 71% increase. Okay.
Yeah, so it's a 71% increase. And so that, yeah, it's an increase. And you know it's an increase because it's positive. Make sure you know that change is absolute value, but that tells you if it's going to go up or down. So continuing based off of this, whenever you're dealing with a percent question, you want to remember percent increase versus percent decrease. How we did that, we just said over here, you add the percent or you subtract the percent from 1. That's one of the biggest things on the SAT you guys really want to make sure you're paying attention to. So over here we have Katerina, a botanist studying the production of pears by 2 types of pear trees. She noticed that type A produced 20% more pears than type B did. Based on Katerina's observation, type A trees produced 144 pears. How many pears did type B trees produce? So the first thing that we want to do here is get an equation relating A to B, right? So if type A is 20% more than type B, what's that
Here,
gonna
Asher, don't write it down. Let's see. Everybody drop it in the chat. What equation would you write with A and B and a decimal? And if you want a private message, Asher, do that. Private message, Asher, what equation would you write down? And the first step should always be write your equation, okay? Hey, Annika, welcome. I'll drop the document in the chat for you. Welcome back. Same document as last week, okay?
Okay, that's correct for adding the percent, absolutely, but we want an equation that relates A and B. So if A is produced 20% more than B, what does that look like as an equation?
So is it an equation for A equals? Is it B equals? What would the decimal be? And what are you gonna attach? Which variable will you attach next to that decimal? This is a perfect example of why you want to make sure you're following percent rules. Because if you don't, you're gonna get this one wrong. How's it looking, Asher?
Let me get a couple more responses, and then we'll go over this for sure.
Daniel, really good. Try to include a equal sign in that equation because that's an expression. Make sure you include A, right, and the equal sign. But Daniel, you're right on. Cool.
Okay, I see a couple of different ways to approach this. Don't worry about different ways to approach this. We just want an equation relating A to B, right? So we have something that's like A equals B. So it could be something A, it could be something B, but let's talk about this real quickly. So if we have 20% more, what's that going to look like? So if I want to write this as percent increase, so percent increase, what does this mean? 20% more. I write that as what? Just drop it in the general chat. Don't worry about anything like that, private or anything like that. What's that look like?
Good stuff, Matthew. Yeah, so the first question I asked yourself, is this a percent increase question or a percent decrease? Second, you see more, you know the decimal that you put in your calculator is not going to be less than 1, right? Really good.
Yeah, perfect. So 20% more means we're dealing with 1.2. Make sure you guys understand that. I saw a lot of responses still that's not incorporating the 1 here, and that's so important, all right? So remember, an equal sign is like a scale, right? It's like a balance. So if type A is more than B, so we have this scale, right? Type A is more than B. How do we balance this out? What do we need to do to B? Feel free to drop it in the chat, like say something out loud, because I can't move my hands. This is my example here. I don't know what to do with my hand. I can't do anything.
Would you multiply B by a number B for bigger or L for less than 1? So right now we have A is more than B, which means to balance it out, you have to multiply B by what? A number bigger than 1, because anytime you multiply a number bigger than 1, it's increasing, right? Awesome, right?
Perfect.
So, and anytime you see like 20% more than, whatever's next to the than is going to be multiplied by, right? So it'd be more than B means times B, or 1.2 times B, right? And then I have like, so we'll set it up like this, and then once you have the equation, you just plug in, and it's really easy, right? So 144 equals 1.2b, divide by 1.2, and drop it in the chat, guys. What's the final answer? Right? So guys, this seems easy, but I promise you 90% of students get this question wrong, okay? I got a question for you, okay? Yes or no? If A produces 20% more than B, does B produce 20% less than A? Yes or no? If A produces 20% more than B, does B produce 20% less than A? Good. No. Okay. Because this is why most kids get it wrong. What they do is like, oh, A is 20% more than B. that means B is 20% less than A. So they just say, okay, they just do 0.8 times 144. And when you do that, what's 0.8 times 144? Because they think that's true. They think, okay, if A is 20% more, then B is 20% less than A. So they just multiply by 0.8. And they get 115.2, and then they pick answer choice A. So like 90% of kids are going to pick A. But as you can see, if the question told you A produces 20%, I mean, B produces 20% less than A, then that equation would be true. But the equation doesn't tell you that. Yeah.
Yeah, perfect. Really good thing to pick up on. Just because something's 20% more doesn't mean the other thing's 20% less, just like Calvin said. That's a really good rule to understand about percentages. So any more questions on this one? Other questions? Because this comes up a lot. Okay, cool. And then here, we're talking about percent change again. We already did this. Actually, let's see. Stella Kuto, what is our percent change formula?
I kind of have it like mixed up. Isn't it? It would be 1 minus. It has like 1 minus or 1 plus.
So that's correct if we're doing percent increase or decrease, right? So percent
Okay.
increase is what?
Wouldn't it be 1 plus?
Perfect. And then percent
Decrease would be 1 minus.
nice. Perfect. Now do you remember percent change though?
Not really.
Okay, so percent change is new, like how a cow moves, but with like an N. So it's N minus O over O, or you can think of it as new minus old over old. And since it's change, you can throw an absolute value on it, but if it doesn't really matter in the context of the SAT.
Okay.
Perfect. Okay, so over here, let's figure out what is the percent change from March to April. Why don't you guys drop it in the chat real quickly? What are we thinking from March to April? What's that going to be? Calculate it yourselves, you guys. You got it. Sweet. Getting some answers already. I have 2 answers already. I got like 6 answers already. So let me get a couple more. Why don't you guys just throw it in the chat? If you don't know how to use this formula again, just ask, because that's why we're doing this. So you guys do understand. It looks like you guys got it. Perfect. So exactly like what you guys said, new minus old over old. So 5 minus 4 over 4. That's going to be 1 over 4. Same thing as 25%. And since it's positive, we know it's a percent increase. But the percent change is 25% regardless.
And real quick, let me go through another way to get percentage. So remember, you're starting with 4 and you're going to 5. So it means to go from 4 to 5, you're going to multiply 4 by some number, right? So we'll say 4 times x equals 5, right? And remember, x is just going to be some decimal or the distance from 1, right? So when you divide both sides by 4, you're going to get what? X equals 1.25, right? And 1.25 would be what? 25% growth, right? So it'd be a 25% increase. Okay, give me one if that makes sense. You can just do like new divided by old and then the distance from 1. Okay? All right, cool.
Sweet. Over here, central tendency, it's mean, average, median, mode, and range. That's really what we're primarily focusing on. Remember, mean or your average is the sum of values divided by the number of terms. Next thing that you have, the median. The median is always your middle value. Next, mode is your most frequent value. And then range is greatest minus least. in your whole data set. That's pretty much it. So given the data set, we can do all this stuff real quickly. To find the mean, Matt Cavero, what would we have to do with these numbers to get a mean?
To get a mean, you just have to get the middle value, which is 1.
Close. So that would be median, but mean is the sum over the number.
Oh, then I think you just add the numbers up and divide it by how many numbers there are.
Nice, exactly. So 1 plus 1 plus 2 is 4, plus 4 is 8. And what are we dividing that by?
By 5.
Nice, perfect, really good. What's our mode, Mac?
Mode is the number that pops up most, is 1.
Nice. What's our median?
1.
1, perfect. What's our range?
4.
Nice, killed it, Mac, perfect. Now, something about median, if it is even. So if there's an even number of terms, you have something like 0, 1, 1, 3, 5, 6, something like this. You know, like the tick strategy, greatest, boom. But remember, if it's even like this, you need to take the average of the two terms in the middle. So 1 plus 3 over 2 gives us 2. So remember, if it's even, there's an even number of terms, you have to take the average of the two middle terms. That's pretty much it.
And for median, it helps you remember, right? If it's an even number, put up like 4 fingers, right? There's 2 in the middle, right? Put up 3 fingers, there's just 1 in the middle, right? So even number. And the easy, I know in school they taught you, okay, cross out the ends until you get to the middle, right? The easiest way to get to the middle is just divide the total number by 2, right? So like 4 divided by 2, we're looking at the second and the third, and then we're gonna add them divided by 2, right? If there's like 150 values, would you rather count up halfway or count from both sides until you get to the middle, right? It's always easier to just go straight to the middle from one side, right? So if you can figure out like which middle value you're looking at, it's gonna make it a lot easier, right? So if there's 500 values, instead of crossing out 499 values or 498 values, you just do 500 divided by 2, and you count up to the 250th. So we're looking at the 250th, 251st value, adding those and dividing by 2, right?
Perfect.
So,
Yeah. And I got a really great question in the chat. Can it be a decimal? Yeah, absolutely. So you take these 2 points, 1 plus 2 over 2 gives you 3 over 2. It gives you 1.5. So even though this isn't in the data set, it doesn't really matter. It's still the median term. So great question. Over here, this is a really great question. Over here, the table above lists the links to the nearest inch of a random sample of 21 brown bullhead fish. The outlier measurement of 24 inches is an error. Of the mean, median, range of the values listed, which will change the most, if the 24-inch measurement is removed from the data. Once you guys got an idea, put A, B, C, or D in the chat, and we'll have a discussion about this, because this is a really great conceptual question. Oh, sweet. Yeah, you guys are going ham. Awesome. So just remember, 24 is the greatest value. It's an outlier measurement. It wasn't supposed to be there. And that means that we're affecting our greatest value. And then from this point, you can think, okay, which one has to do with the greatest value directly? And then remember, range is greatest minus least. So if you take the greatest out, you're definitely impacting the range the most. Median doesn't change that much because it's going to shift from 12, about 12, to about 12, maybe 12 plus 13 over 2, something like that. So that's not going to change very much. Your mean's not going to change very much either. It's pretty hard to change your mean when the values are really close like this. So 24 is not big enough to really sway your mean that much. So don't worry too much about your mean. And then range is definitely correct because it decreases from 24 to 16. So that's a decrease of 8. And moving forward, standard deviation, it sounds really tough. It sounds hard. It sounds intimidating. It's not too bad though, you guys. So to be a deviant, you can think of like the Subway Surfer dude because he's like spray painting walls. The police is like chasing him and all stuff. Like a deviant is something that doesn't follow the average or the rules, right? So a deviant, like spray painter is automatically what I think of, right? Standard deviation is measuring how many points are away from your mean, like how far away from your average are your points, and that's it. So if it's closer to the mean / middle, that means you have less deviance or a less standard deviation. If you're further from the mean / middle, so your points are away from the middle, that's a higher standard deviation. So let's say we have set 1 or set 2. Which one has a higher standard deviation? We're looking for the one that has the most points away from the middle. Okay, I'm getting some answers. Don't be shy, just throw what you think, and we'll definitely talk about it. If you have to guess, feel free to put a question mark. This isn't like an SAT question.
And real quick, Asher, maybe like under, you just write 1, 2, 3, 4, 5 under each of those sets. So
Sure.
this is like a frequency table, right? So basically 1 appears once, 2 appears like twice, 3 appears, right? So in both cases, right, what would the mean be in the chat? The mean would be what? Since it's an even distribution, the mean would be what value? What do you think? Drop it in the chat. 1 through 5, what number would the mean be for both sets? Really good, right? So the mean would be like the same. It would be 3 for both. But since deviation, remember, like just like Asher said, to deviate means to go away, right? Set 1 has more values at the mean or right around the mean, so there's less deviation, right? Set 2 has more values that are far from the mean, which means there's more deviation, okay? Give me an S in the chat if standard deviation makes sense. If you have more values away from the mean, it's more deviation or higher standard deviation. More concentrated means lower deviation, right?
So the more clumped towards the middle, the better, just like Kelvin said. Like ideal scenario, it's just everything is the same thing. And then the next ideal is like, okay, most things are the same things, and then on the outsides, that's the highest frequency still. And like over on the outliers, like 1 and 5, they're not very frequent. But over here, you see the outliers 1 and 5 are super frequent, and then the mean isn't really that supported, right? So yeah, really good stuff, you guys. Set 2 has higher standard deviation, so SD up. And that's pretty much it. So for stats and probability, what we have for our standard equation is going to be what you want over what you have. So this is the bit that you desire over what you have. And by what we have, that means the total given some parameter. So total given a parameter. So what does a parameter look like, you guys may be thinking? So if there are 7 marbles, 2 blue, 2 red, and 3 green, what's the probability of drawing red given it's not blue? So that means our given here is saying that it's not blue. So what is our new title given a parameter? I mean, what's our new total given our parameter?
So remember, sometimes the total will be like the grand total. Sometimes the question is going to be really specific. So anytime you see like given that, or like if you're drawing from a certain thing, the word from it affects the total as well, right? Good. So the total was 5, but now since we're not drawing from blues, right, we're going to cross out. So anytime you're doing probability, cross out what you don't care about, right? So we're not picking from blues, so we cross it out, and now there's only going to be red and green, which is 5, right? And then what do we want? We want a red, right? So what would that be? What over 5? Good stuff.
Perfect. Yeah, you guys are killing it. Awesome. So 1/2, 2/5. Excellent. Give this one a shot, A, B, C, or D. Just want to make sure you guys are really picking up on these concepts because they are tricky. And at about this point is where you should be able to solve it. So just drop any answer in the chat, or if you're between a couple answers, just drop the one that you are good with. Cool, 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 cool. All right, looks like everyone got D. Really good stuff, you guys. So of the people who chose vanilla, that means that that's our parameter, right? Of people who chose vanilla, what fraction of hot fudge is a topping? 8/13. 8 plus 5 is our total. 8 is what we want. That's 8/13. You guys killed it. Perfect. Charts over graphs. We don't really need to care about much about these guys. I know you guys know how to read bar graphs, line graphs, all that. Just know that bar graphs, category, line graphs by time. So it's talking about how something changes over time. With a pie graph, that's something out of 100%. So it shows how much out of 100% something is. In a table, again, it's just categories, different categories, how to read that, that's fine. Scatter plot, though, I do want to emphasize this real quickly. If I'm asking about actual data versus an estimation, it says actual or estimation. So feel free to put A, actual, E, estimation in the chat real quickly. It's really important you guys understand this. What are we thinking? Actual or estimation? Perfect. So the dots are actual data. That's actually in our data set. The line, though, is an approximation or estimation of our data. So it's saying, based on all these dots, here's what our line should look like. That's all that's saying. So coming over here, that's all that is. So you got individual data points. And a trend line. And this will show you correlation. Either it's going to be positive or negative or strong or weak. So you can have weak strong or negative / positive. Like these are the two things. So you can either have a weak negative, a strong negative, or a weak negative, a weak positive, strong negative. I mean, strong positive, like that.
And then also direct or inverse, right? So if like one increases and the other increases as well, like this, there's like a direct relationship. If like you have like a negative line, that means it's gonna be inverse relationship, right? And then also drop it in the chat real quick. Anytime you have a graph, chart, or like figure, what's the first thing you always read? Drop it in the chat. The title, okay? Always read the title. It's just gonna help you understand the chart better. And then the axis, and the last thing you look at is actual data, okay? And then real quick for like those circle, what are those things called? Circle plots, with the percents.
You're talking about the pie?
Pie, yeah, pie charts. There you go.
Yeah.
Okay. All right. So yeah, guys, for whenever you have pie charts, you can set up proportions, right? So let's say like one of them like has like 20%. You could say 20, and they actually give you a number and a total. You could say like 20% means 20/100 equals like, let's say there's a total of 75 people, equals like X over 75 or something, right? Yeah. Okay. So with pie charts, you can set up proportions based on the percent.
Nice, nice. Perfect. Last thing, we have surveys. Not too bad. Don't worry about this too much, all this stuff. You really just want to make sure it doesn't sound biased and you're going to be in good shape, right? So the group being studied is your population. Those chosen to be studied should be biased. I mean, unbiased. And it should be greater than 30 people, greater than or equal to 30 people. People. And then when we're drawing conclusions, specific, likely, not certain. So the real main thing to keep in mind here, surveys are also approximations. So use approximately. Use words that indicate approximately whenever you're dealing with surveys, okay? Remember, drawing conclusions, surveys are approximations. So that means that it's not going to be actually indicative of real life, right? So if like you have like 30% of people in a survey hate something, that doesn't mean that 30% of all people in the world hate something. It's an approximation of whatever sample it's supposed to be indicative of. So let's check this out real quickly, figure out what's wrong with this question or this survey, and let me get A, B, C, or D in the chat real quickly. Really good stuff, you guys. So, Sophia Hung, why don't you explain why you got D? How'd you get that?
Well, the council only surveyed the people who own dogs, and they didn't like survey all city residents.
Perfect, yeah. If you only survey people who own dogs about a dog park, kind of whack, right? Pretty biased. So excellent stuff, you guys. It's going to be D. That's the sort of stuff that you got to watch out for in questions like this. And that's pretty much it. So that's core 4. If you guys have any questions about percents, thank you, Logan. I appreciate it. A round of applause. It's our second to last core. That means we got one left, and then you guys are home free. You guys are chilling. So any questions about any of the topics we covered? Inequalities, different statistics, percent change, fractions, all that stuff, proportions, absolute value, anything at all, y'all. Okay.
And guys, I'm gonna make sure to send you. So you guys should have all the core documents and annotations saved, but I'll make sure to send it all to you in like one email. You guys will have a practice test this coming weekend on Saturday from 12 to 4 p.m. Okay, so just make sure you mark your calendars. Review all the core documents. Okay, we went through active reading. We went through the writing 101 packet, which is like 26 pages. We went through core 1 through 4. We'll finish core 5 next week, but we'll send core 5 and the annotations with just so you guys can look over it at least. But make sure you review over those concepts and use the strategies when you're doing the test. Okay.
Yeah. So let's talk about dimensional analysis one more time before you guys leave. It's really easy to say, okay, I'm going from inches to feet. I'm going from feet to inches, so I know I need to multiply by 12 instead of divide by 12 and do it like that. That's okay for the really simple ones. But sometimes you're going to have really complex dimensional analysis on the SAT, and you're going to be like, oh crap, I don't know what to do here. So this method will work every single time. If you guys take chemistry and you have to do all that dimensional analysis in chemistry, this is going to make your life a little bit easier doing all these conversions. So remember, whenever you're converting, think, what unit do I want? I want inches. You put the desired unit to the right of the equal sign automatically. That's how I started off. Then you look at what you have. So I have feet. Okay, so I got 15.5 feet. And you multiply that by your conversion. And remember, in order to get inches, you need to put inches on the top. In order to get rid of feet, you need to put feet on the bottom. At that point, you just put the conversion ratio in. So they're 12 inches in every 1 foot. It's going to make that way easier like that. So Daniel, does that make a little bit more sense? Do you have any questions about this?
Could we walk through 6? Just
6?
walk through it.
Yeah, for sure. Yeah. Really great question. So we're talking about 2 decagram containers, and we're asking how many 1 milligram doses are there in 1 2 decagram container. So first, we have decagrams to grams, then we have grams to milligrams. So we're asking about milligrams. That's what we want on our right side. So over here, we'll put mg. But what we're starting with is 2 decagrams. So we have 2 DEC, that's what I'm going to call decagrams. And the first thing that we're gonna get this into terms of is grams, right? So what's my conversion ratio gonna be? What over what?
10 grams over 1 decagram.
Perfect, because that's what we want to get rid of, right? And that's why it's on the bottom. Perfect. 1 dec. And then we're multiplying this in order to get milligrams. So what do we what's our conversion factor over here?
1,000 milligrams over 1 gram.
Yeah, exactly. So we put what we want in the numerator. So we want milligrams. So we put 1,000 milligrams over 1 gram, just like that. And then you just multiply. So 2 times 10 times 1,000 is the same times 2 times 10,000, which gives you 20,000 milligrams. Does that sound good, Daniel?
Thank you so much. Yes, sir.
Yeah, absolutely good. Really great question. Perfect. Awesome. Okay, sweet. So that's dimensional analysis. Any other questions you guys got on any of this? Inequalities, remainder. Whoa, we did remainder theorem on this already. Cool. All that stuff.
Let's do an example of remainder theorem one more time.
Okay.
So let's say you had something like, let's zoom in. Let's say you had something like x squared plus 5x minus 3. You can either do long division to get the exact solution, right? Oh, my bad. Divided by x minus 4. Okay. So we can either do long division to solve like what the exact solution would be, or we can just do the shortcut, find the remainder, right? So what are we going to do? First thing, what are we going to plug into the top, guys? What number? Drop it in the chat. What number are we going to plug in to the top equation to find the remainder? Really good, right? So all you got to do is find the 0 of the denominator. So x minus 4 equals 0. X equals positive 4, right? What number is going to make the denominator 0? Then plug that value in for x into the numerator, right? So the remainder, r, is going to equal what? 4 squared, right? R equals 4 squared plus 5 times 4 minus 3, which would be 16 plus 20 minus 3, which would be what? 33. So that would be the remainder. So whichever answer has like plus 33, and the remainder always goes over what you're dividing by. So the end of the solution should just be plus 33 over x minus 4. I mean, yeah, 33 over x minus 4 would be the remainder. Give me an R in the chat if remainder theorem makes sense. Cool.
Perfect. All right. So we pretty much went over everything today that we're going to go over. So unless you have any other questions, like Kelvin said, we have a practice test this weekend. I want you guys to make sure you're prepped up for that. Just like Kelvin said, review the documents, do all that stuff. Stay on top of your homework, you guys. All this, Sarah, that's really going to help you guys a lot. Make sure you're doing all that. If you don't have any additional questions, have a great rest of your day. If you do,
Before you go, I'm going to drop core 5 in the chat. And I'm also share the annotation. We'll make sure to go over it together. But if you want to, just review it, review these 5 documents before your practices, okay? It'll be super, super helpful, all right? And make sure you go to office hours, right? Every day of the week, if you have any questions on like material, practice tests, etc., come through. See ya. Bye. Have a good one.